Okay. Sorry, I didn't say that. Shucks. I'm so over this. Oh, that's a really good idea, David. I like it. Let's do that. I just don't have to write all that. Okay, wait, no. Let's do the other one. Because I didn't record my 10 o'clock. I got to record this one. So we'll do it on the docket. Okay. Focused? Yeah? Okay, quantity. Remember we said that quantity was going to be the input of all of our functions? Because that way we can work with them together. So like if I find a quantity that, say, maximizes profit, I can use that quantity in my price function or my cost function or my revenue function to find the corresponding cost or price or revenue because they all take the same input. So quantity is going to be our input for all functions. So that's X. And that's, I don't want to write it there. Input for all of them. And then, well, what do they give us? They give us a price function. So price, it's lowercase p of x. Remember, we are going to have an uppercase and lowercase p. So just be careful that you can distinguish between the two. And that is 600 minus 5x. Glare. There we go. That's better. And then they also give us cost. So C of x equals 200x plus 1,500. So now we need to come up with a revenue function and a profit function. So we'll start with revenue. So remember, revenue is price times quantity. And that will be given to you on the test. So you'll have a little box of formulas. It'll have the price times quantity for revenue, and then the revenue minus cost for profit as well on there. So this is x times 600 minus 5x. So we'll just distribute, and we get r of x equals negative 5x squared plus 600x. And then the last one I want to do is profit. So our profit function is capital P of x. And then profit, remember profit is like how much money you actually like pocket. So it's the money that you take in, so your revenue, minus the cost that you have to pay to produce the items you're selling. So that's our cost. So this is negative 5x squared plus 600x, and then minus, and then be sure to put that cost in parentheses so that you're subtracting both terms and instead of subtracting the first term and like adding the second. So minus, where's my cost? There it is. 200x plus 1500. So you'll distribute that negative, and we end up with P of x equals negative 5x squared plus 400x minus 1500. So now we have a list of all the functions we could possibly need in this whole problem. And so the key to all of these is just asking yourself what function to use, and then if you're given an input or an output. So probably the tricky part is like which function to use. And I swear, like, these aren't trick questions. Like if they're talking about finding the price, for real, definitely use like the price function. If they're talking about finding the revenue, you should use the revenue function. So like just look for the word and go back to that function. So I'm just gonna take these. So we have that in front of us. There we go. Oh, not that low. Oh, I'm going to have to scoot down anyway. Okay, we'll go like that. So part A, find and simplify a revenue function first. Hey, we already did that. So all we have to do is copy. So we found our revenue function. We have r of x equals negative 5x squared plus 600x. And then we want to know what price we should charge if we want to be able to sell 50 scooters. So when I see what price, I think I should use what function? The price function. So we're going to use lowercase p of x. And when you do your list, be sure to use the words too. Like don't just write like p of x, c of x, r of x, p of x, because then it becomes a lot harder to figure out what exactly you need, especially with the two p's. So we'll take our price function, and then if we want the output, that means they have to give us the input. So they do indeed tell us 50 scooters. So x is 50. So we want to find p of 50, which is 600 minus 5 times 50, which is 350. So to sell 50 scooters, charge $350 per scooter. And as far as your sentence goes, like I'm not going to be super picky as far as like grading, like about how specific you are. However, throughout this problem, we're going to be talking about like several different quantities. And so if we want to be able to keep track of which quantity to use where, it'll help if your sentence like tells you the correspondence between the quantity and then whatever output you get. That way, like, you know if you want to use 50 because you know if you're using a price of 350. So anytime at this point, because we know that a quantity of 50 scooters corresponds to a price of 350 scooters, I could then be like, okay, well, if my price was 350, what would my revenue be? And that tells me I have to put x equals 50 in for my revenue because the quantity that corresponds to that price is 50. So I can say, instead of giving you that input, I could give you that price, and because I know that input corresponds to it, I can use x equals 50. So if we have all that information in the sentence, then we can find it when we need it, rather than just writing like the price is $3.50, because we're going to have other prices as we go. So now I want to know what the revenue is if we sell 50 scooters each month. So again, they give us the quantity, x equals 50. And we want to know what is the revenue. So I should use the revenue function. So we're going to evaluate R of 50. So R of 50 equals -5 times 50 squared plus 600 times 50, which gives us, I think it's 1750, but you guys might want to check. Yeah. Or 17,500. Yeah? Okay, so $17,500 of revenue is made from selling 50 scooters. Selling 50 scooters. There's another way we could have found that. How is it? Yeah, we could have just, since we knew that, since we got the price in part B, we could have just multiplied 50 times 350, and that should give us the same thing. That's a good way on a test to check and make sure you're doing the right thing, too, is if you do it using the function and then you do it by just multiplying the numbers and you don't get the same thing, then maybe you use the wrong function or something.
Are you going to care which way you do it?
No. As long as, I'm trying to think of what problem that was. There was like a problem where, like as long as you remember not to always use the same price and quantity, like eventually you might have to switch to the actual function because like our price isn't necessarily always going to be $3.50. I'm just remembering a problem from last year where they got the numbers in like the first part and then used them and then never actually ended up coming up with the revenue function to be able to maximize it later because they didn't need it there. So as long as you use it when you need it, that's fine. So then part D says what number of scooters maximizes revenue. So what function should I use? Yeah, the revenue function. Remember we talked about yesterday, whatever it is that you're maximizing or minimizing has to be the output of your function. So the output of the revenue function is revenue, which means that I have to maximize the revenue function. Another thing that sometimes gets tricky as far as just like figuring out what to do on these problems is like some people get mixed up about using vertex formula and using like Pythagorean theorem, like when you set it to 0 and when you're finding the vertex and the whole thing. Remember that the only time we find the vertex is if we're finding the maximum or minimum of the function. So one clue that you want to find the vertex is that they don't give you an x or a y value. Like notice that in D, they don't give me an input or an output. Like they don't give me a quantity, and they don't tell me what the revenue is. So I can't plug anything in for x, and I can't set my function equal to anything. So that's a good clue that like we're looking for the vertex because there's nothing to calculate otherwise because they don't give us any information about either quantity. So when you see the word maximize, so maximize, minimize, most, least, biggest, smallest, greatest, largest, least, I said that one already. All of those things, those words are clues that you want to find the vertex. So vertex. So I'm finding the vertex of the revenue function. And remember, yesterday I told you guys minimizing is exactly the same as maximizing. So for you, the process will be exactly the same, like if I were to say minimize rather than maximize. What determines if you find a minimum or a maximum when you get the vertex is just the function. So once you have the function, it either opens up or down. So the vertex is either a minimum or a maximum. So using that same process will get you either one, depending on what the function is. And I'm not going to like give you one that opens up and be like, find the maximum. That'd be mean. There is no maximum. So we're going to find our vertex. We're using x equals negative b over 2a, so negative 600 over 2 times negative 5, which is 60. Again, remember to keep that x equals, because you want to be really aware of like what you're actually finding. So here we found an x value, so that's a quantity, which is the number of scooters, which happens to be what we want here. So even if I didn't know that, I'd probably get it right. But like on your homework last night, there was a question like, what is the maximum height, right? And if you use the vertex formula, it doesn't give you the height. It gives you the time that that height occurs. And you have to plug it back in. So like be sure that you have that like x equals or t equals or whatever it is, so that you can like be aware of what you're actually finding with respect to like what the answer is. So 60 scooters will maximize not profit, revenue.
What was the formula before putting in the 600?
So the vertex formula gives you the x coordinate of your vertex, and it's negative b over 2a. And that will also be in your little formula box on the test.
Is that one only for when it's in general form, or is that just all the
Yes, it's only for general form. So that's like when I wrote our functions, like I distributed and combined like terms, so that these are all in general form. Good question, thank you.
How would we find the y coordinate then?
So if you wanted the y coordinate, you would just plug that x coordinate into your function.
Ideal.
Well, depending on what you wanted the y coordinate of. So like if this question asked what is the maximum revenue, I would start the same way and find that 60 scooters maximize revenue, and then I'd plug that 60 into r of x, my revenue function, to get the maximum revenue. And remember, if it's not in general form, guys, you can find the vertex, like if it's in standard form, the vertex is just in the function, right? Like the h and the k. And then if it's in factored form, I mean, you could multiply it out to put it in general form, but you can also just, you know how you can get the x-intercepts really easily from factored form, right? Like they're just those two numbers, like the m and the n. If you average the x-intercepts, you'll always get the x-coordinate of your vertex. So that's how we came up with that vertex formula. So you can do it that way too, if it's not in general form. Okay. Part C. Hey, Dan, for part C, what function should I use?
revenue.
What am I looking for? Yes. So in this one, we see both the word price and the word revenue. The way that I know I'm using the price function is that it says what price. So the answer is going to be a price, which means I need an output of the price function. So this right here tells me to use my price function. And so why the heck are they talking about revenue? Well, back here, when we found the number of scooters that maximizes revenue, we found an input for all our functions, right? We found a quantity, which means that now anytime I talk about maximizing revenue, I can use x equals 60. So once you get this 60, you're going to use x equals 60 for any question about maximizing revenue. I can't write in a straight line to save my life. So now we have the quantity that gets it done. We can use that anywhere we want. So going back to part E, if I want to know what price I should charge in order to maximize revenue, then I need my price function to get a price. And the input of that is going to be 60 because 60 is the quantity that maximizes revenue. So when I see maximize revenue, it doesn't necessarily tell me to use my revenue function. It's just telling me that X is equal to 60. So it's just another way of giving that quantity. So we have P of 60. This is lowercase p for price equals, oh, I lost my doohickey here. Oops. There it is. 600 minus 5 times 60 is 300. So to maximize revenue, charge $300 per scooter. So now, based on the given mathematical models, what is Silver Scooter's maximum possible monthly revenue? James, what function should I use?
Revenue function?
Yep. So the question is asking for revenue. So what is the monthly revenue? So I want to use R of X. And I also see that I want the maximum. So if we're talking about the maximum revenue, then we know that the quantity is 60. So this tells me that X is 60. So I can evaluate R of 60. So R of 60 equals -5 times 60 squared plus 600 times 60. Which is 18,000. So the maximum revenue is $18,000. Okay, moving on to cost. What is the cost to Silver Scooter of producing and selling 50 scooters in a month? Notice we're not using X equals 60 anymore because it doesn't say anything there about me wanting to maximize revenue. It just says I want to sell 50 scooters. So that means my quantity has to be 50. So like what X is isn't going to be set in stone throughout the problem. It just depends on what you're trying to do. So the 50 scooters tells me that X is equal to 50. And then I want to know what is the cost. So I'm trying to find a cost, which means I have to use my cost function. So we'll evaluate C of 50. It's 200 times 50 plus 1,500. Gives me 11,500. So the cost for 50 scooters is 11,500. Okay. Next, find and simple. Ooh, we did that already. So just go back to your list. Can't write the word cost apparently. And p of x is negative 5x squared plus 400x minus 1500. Shelby, for part I, what function should I use? Yes, very good. So it asks for a profit, right? It says, what is my profit? And so I'm looking for the output of a profit function. So I'm going to use capital P of x. And then again, we're selling 50 scooters, so that's my x value. So P of 50 equals negative 5 times 50 squared plus 400 times 50 minus 1500. I don't remember that one. You guys get to help me out.
6,000.
6,000. Thank you. So the profit for 50 scooters is $6,000. Nina, for part J, what function should I use? Mm-hmm. So I'm trying to maximize profit, which means that the output of the function I use has to be profit. So we'll use that profit function. This tells me P of x. And Trey, what do I want to do with my profit function?
Don't you need to use the, like, negative b over 2a?
So I want to find the vertex. X equals negative b over 2a. So because we see the word maximizes, I want to find the vertex. So we have x equals negative b, so negative 400 over 2 times negative 5, which is 40. Which might seem a little bit weird, like it kind of seems like if we maximize revenue, we should also be maximizing profit, right? Like, how is it possible to maximize revenue at 60 scooters, but then like make less money or make more money if we sell 40? Have you guys heard of the law of diminishing returns? Really? So it says that eventually it's not going to be more profitable to like sell more items. So for like instance, if like in this situation, maybe the factory that I have that makes scooters has a capacity of like 50. Like I can make 50 scooters with the manpower and machinery that I have. So if I want to make 60 scooters, I have to go rent like a whole new factory and buy like all new equipment, which doesn't make it very cost effective for me to actually sell 60 scooters. 40 would make me more money because I don't have to put out all those other expenses. So eventually, that's why it's a parabola, because eventually making and selling more doesn't actually make me more money. So we're going to maximize profit at 40 scooters. So 40 scooters will maximize profit. Which means that I'm going to use a quantity of 40 for any question about maximizing put it there. profit. Okay, K and L are all you. Okay, Anna, did you get a price?
$400.
So to maximize profit, charge $400 per scooter. Does anybody want to see how we did that? I think I saw 400s all the way around, but does anybody want to go over that? Yeah? So we see here that it says what price, which tells us to use our price function. And then here we see that we're maximizing profit. So anytime we're maximizing profit, now that I've found the quantity that will maximize profit, that's going to be my X value. So my X is going to be 40 because that's the quantity that maximizes profit. So we do P of 40, so lowercase p of 40. And that's 500, it's 600, huh? 600 minus 5 times 40. Does that make sense, James?
Yeah.
Good. Lily, what'd you get for profit?
6,500.
The maximum profit. Is 6,500. And again, we see that we're maximizing profit. So as soon as I see that, I know my X value has to be 40. And then it asks me what the profit is. So what is profit? And that's what tells me to use my profit function. So uppercase P of X. So we plug 40 into our profit function. We should get 6,500. Is that good? Okay, so the other thing I want to do today in the last few minutes that we have is, so on last night's homework, were there any questions that you wanted more explanation on or you had trouble with? Because we have, we didn't finish yesterday's notes, but there's problems on yesterday's notes that correspond to all the ones on last night's homework. So if there was one you were having trouble with, we can look at that example from yesterday.
These the outlines of the.
Oh, that was just, here, let me put it up while we're waiting for people.